Let's see one other type of relationship between two entities. Assume that we have this again this same employee entity type, and this is the employee entity set, and this set contains all the entities related to employees. Each element it refers to one employee. And let's say there is one more entity set, and the entity type is project, and this contains all the entities, and each entity here represents a project, right? And according to the specification of the function, this in requirement analysis, let us say you got the information that every employee is supposed to work at least on one project, and he can work on many projects, as well as every project is supposed to have many employees, and it is supposed to have at least one employee. Okay, so again watch it, listen to this. Every employee is supposed to work on at least one project, and an employee can work on many projects. Similarly, a project can have many employees, and every project is supposed to have at least one employee, right? So at least and many, both sides, right? And now let's define a relationship, and you can choose a meaningful name. Let us say the name is, since here I have written employee and there I have written project, let me write employee works on project. That looks meaningful, right? Employee works on project. That's it. And now I have to take each relationship and associate it with one entity from here and other entity from here. See, in some sense you can even think of it like this. There is one set and there is other set, and you are actually taking a cross product of these two sets, and a relationship is nothing but a subset of cross product. Just like in mathematics, in set theory you might have seen it, right? What is relationship? What relation is a subset of cross product. Here also a relationship can be actually visualized the same way. How? You are taking this set and you are taking this set, and you form all the cross products, which means all the elements possible by cross producting this one and this one, right? Cartesian product. Then you are going to get some set. From that set you are going to take subset of it, that is going to become relationship, isn't it? Now let us say employees are like this: E1, E2, E3, E4, E5, E6, E7, E8, and the projects are like this: P1, P2, P3, P4, P5, P6, something like this, P7, P8, right? And assume that the working relationships are like this. Project P1 is having employees E1, E2, E3 working on it, and project P2 is having employees E2, E4 working on it. Project P5 is having employee E5 working on it, and project P6 is having P4 is having employees E1, E5, E6, so on, right? Let us say this is P3 and P4. Okay. Now how are you going to relate them? So there are 4 projects and these many employees. Is there any employee left out? Let us put E7 here and E8 here, right? So according to the specifications, they are saying that every project is supposed to have at least one employee. At least one means you can have many employees can be working on that project, and moreover every employee is supposed to work on at least one project. Therefore all the employees have to be covered. See this, E1 is at least present here, E2 is here, E3 is here, E4, E5, E6, E7, E8, right? So every employee is actually working at least on one project, so the requirements are met, right? Now let's see how this one is modeled. So E1 is related to E1, E2 and E3 are related to P1. Therefore E1 is related to P1, and again E2 is also related to P1, and again E3 is also related to P1, right? So I am forming each relationship using one entity from here and other entity from here, right? So you might think that why don't I put a line from here to here, and then these 3 lines only to one point and then there. But actually the relationship is formed by taking one entity from here and other entity from there. You are not supposed to form by taking many entities from here, from the same set, and then one entity from the other set. That is why every entity, relationship entity, is formed by taking one entity from here and one entity from other side, right? And next one is See, these questions are very simple, but if you don't understand them clearly, there is a chance that you might make some mistake. They are very simple to answer, especially DBMS. Only thing is the terminology, you should understand it, and I know the representation. So the things are very, very simple. You'll understand it, okay? Now, next one is P2 is actually related to E2, E4 and E8. So E2 is related to P2, right? And then E4 is related to P2 and E8 is related to P2, right? And next E5 and E7 are related to P3. So E5 is related to P3 and again E7 is also related to P3. E7, let us say, is related to P3. And what about E4? E1, E5 and E6 are related to P4. Let us say P4 is here, right? And E1, E5 and E6. So E1, E5, E5 and E6. Yeah, E6 is from here. This is related to P5, right? Okay, now that is how it looks like. Got it? So what is the specialty of this type of relation is? So one thing is, let's talk about the degree. Degree is number of entities participating in each relationship. How many entities are participating in each relationship? 2 entities. Therefore, degree of this is 2, right? And what about the cardinality? Cardinality is maximum number of relationships in which each entity can participate. So what about the cardinality of this side, employee side? How many relationships can each employee participate in? Many relationships, right? So cardinality of this one is n. What about the cardinality of this? How many relationships is each project participating in? Many. Therefore you can write n here, but instead of writing n and n, maybe that might lead to a confusion saying that equal cardinality. Let's write n and m. N and m, anything which is not either 0 or 1 or like this. M means any number, right? Generally n and m are used to indicate anything greater than 1. So by writing n and m, you can understand that it is greater than 1. What does it mean? Maximum n and m means they can participate in more than one relationships, right? And what about the participation? So participation means total or partial participation. So every entity here is participating at least in one relationship, therefore total participation, right? And what about the total participation here? Here also every project is at least participating in one relationship, total participation, right? Now how can we represent it in both the representations? If you say this is employee and this is works on and this is project, the relationship between these two, see, it is total participation, therefore double line. And what type of mapping is it? Cardinality, m is to n, right? You can put m here and n here, no problem, not an issue. Either m here or m there, anything. Both of them indicate it's a many to many relationship, right? And in case of minimum and maximum representation, min-max representation, it is the employee, it is the project, and it is works. What is min-max representation for this? What about the minimum here? Minimum is 1. And what about the maximum? N. And what about the minimum? Minimum is 1 here and maximum is m, right? You can write anything there. Okay, so that is the representation of various things here. And you can even, sometimes in the exam they might give you a role also in the brackets, so don't get confused. In brackets they can say employee as some name, as a project worker, and that one as the employer, something like this. Role will be given. So anyway, only these questions are possible on this, right? Fine.